Hello there, Mr. Sutton here, bringing you the Algebra 2 10-6 homework solutions on modeling with trigonometric functions. For the first few problems on this problem set, they want us to find the frequency of a function. So to do that, we know that frequency is the reciprocal of period, but we have to find the period first. So in this problem, that's going to be 2 pi over the invisible b value of 1 right here. So that's our period, is 2 pi. And then the frequency is just going to be the reciprocal of this, so 1 over 2 pi. To find the frequency of this function, let's get the period first. For that, we're going to have to do 2 pi over the b value of 3 pi. So we can reduce that to 2/3. And then the frequency is the reciprocal of the period, so the frequency then would be 3/2. To get the frequency out of this function, we're going to want to find the period first. So that's going to be 2 pi over the b value of 0.75. And I'm going to call that 3/4 just to make the next step a little bit easier. So now I'm going to flip this, multiply by the reciprocal. So we have 2 pi times 4 over 3. So that's going to be 8 pi over 3. Now that I've got that turned into a single not complex fraction, we're going to get the frequency by taking the reciprocal of this. So that ends up being 3 over 8 pi. On this problem, they want us to write a function for the sinusoid in the graph here. So we're going to start by getting all the different components of our sine or cosine transformational form, starting with a. So our a value, our amplitude, is going to be half the height. So for that, we can do the max of 4 minus the minimum value of 2 and divide that by 2. So that's going to be 2 over 2, or 1. Next up, we need the b value. Before we can get that, we need the period. It looks from this graph like we've got a period of 2. From the y-axis to 2, that gets us from middle going up to middle going up. So then my b value is going to be 2 pi over the period 2. So the b value then is going to be pi. Next up, let's get the k value, the midline. That's going to be max plus min divided by 2, so 4 plus 2 over 2, which gives us 3. And for the h value, I'm just going to go with the easiest one here and take the spot that's right on the y-axis. So that's the middle of the wave going up. That's where the sine cycle starts. So for sine, I can use an h value of 0, which is kind of nice. And now let me tie all this together. So here's my general form. A sine b x minus h plus k. So we have the a value 1, which we don't have to write. We've got sine of the b value pi. And then we have x minus 0, which we can just write as x, plus the k value of 3. To write a function for this sinusoidal graph, let's come up with a few different pieces. Let's start with the a value, the amplitude. That's going to be max minus min over 2. So -1 minus -3 over 2. So that's 2 over 2, which is 1. That's how much we're fluctuating from the midline up and down. For the b value, let me first get the period. So from top to top here, one full cycle is a distance of 2. And then the b value is 2 pi over that, so 2 pi over 2, which comes out to pi. Now for the k value, we're going to do top plus bottom divided by 2, so the average, that's going to be -4 over 2, which is just -2. And just looking at the graph to confirm, it looks like -2 is the midline for this thing. And now for the h value, I'm going to take a look at the y-axis here and see if there's an easy part of the wave that I can pick out there. It looks like that's the top of the wave, which is where cosine's cycle starts. So if I want to use cosine, I can use an h value of 0 or vice versa. Cosine and h value of 0 go together here. Okay, so putting it all together, we've got the positive a cosine b x minus h plus k sort of format that we're going to put all this into. So for the a value, we have an invisible 1 that I don't have to write. Then we have cosine of pi for that b value. And we have x minus 0, so that's just x. And then finally we have plus the k value of -2, so -2. For this problem, to write a function for this, let's start by getting the a value. That's going to be max minus min divided by 2, half the height. So 1 minus negative 1 over 2. That's 2 over 2, which is 1. And for the period, it looks like from, let's see here, it's kind of hard to tell, but we're going from top to top right here. That's a distance of, let's see, from 3 pi back to negative pi, that would be 4 pi. And then the b value is going to be 2 over the period of 4 pi. So that reduces to 1/2. For the k value, we're just going to average the max and the min together. So 1 plus negative 1 over 2, which is just going to be 0. And the x-axis does appear to be the midline, so that's accurate. For the h value, if I look at the y-axis here for an easy h value of 0, it looks like we're at the middle of the wave going down. That's where the negative sign function begins its cycle. So for negative sign, we can use an h value of 0. If we want to avoid having a non-zero h value, we can go with that one. So putting it all together then, my general format is going to be negative a sine of b x minus h plus k. So I've got a negative invisible 1, which I don't have to write the 1. We have sine of 1/2. And we have x minus 0, so just x. And then plus k, there is a 0 for the k value, so this is actually done. For this problem, we're told that a sound consisting of a single frequency is called a pure tone. An audiometer produces pure tones to test a person's auditory functions, and produces a pure tone with a frequency f of 2000 hertz. That's 2000 cycles per second. Now we're told the maximum pressure produced by the tone is 2 millipascals. So we want to write and graph a sine model that gives the pressure, P, as a function of time in seconds. Okay, well, if we're being asked to give a sine model, let's get all our different pieces, A, B, and all the rest of them. So the amplitude, the A value, that is going to be related to this P here. In general, the amplitude is a y value. It's sort of an output sort of piece to any function. And this is the output variable here, is this P. We're told that the maximum pressure is 2, so that means we can go up at most 2, and then presumably if they want a sine function, this has to go down 2 as well. There must be a positive, negative sort of component to this. So we're going to say our A value then is this 2 right here. And they want a sine function, so we'll use that as our general sort of guide here. So we have an A value of 2. For the B value, well, first we need the period. And they didn't give us the period, but they did give us the frequency. If the frequency is 2000, the period is going to be 1 over that, the reciprocal. And then the B value is going to be 2 pi over 1 over 2000. So if I do a little same change flip here, I've got 2 pi times 2000, which is 4000 pi. Now how about the h and the k value? Well, if we're using a sine model, and actually even before I worry about the h value, let's talk about the k value, because I always talk about that before h. We're oscillating, it looks like from 0. They didn't explicitly spell this out, but we have a max of 2 and we're going back and forth. So presumably then, since we're oscillating from 0 for the pressure, our k value should be 0. This thing should be kind of centered on the x-axis. Now to actually talk about that h value, since they wanted a sine model, that means that this thing should be starting the sine wave on the y-axis at time 0. So that means we can assume an h value of 0 for this one just based on the way they worded this problem. So putting all this together then, I can write P of t equals, and then we have an a value of 2. We've got sine of the b value 4000 pi. H was 0 and k was 0, so we just stick a t on here next to the b value, and that's as good as this one gets. On this problem, we attach an LED light to the spokes of each of our bicycle wheels. That's a good, safe practice to get in. And then on one wheel, the highest point of the light is 22 inches above the ground. The lowest point is 4 inches. While riding your bike at a speed of 12 miles per hour, the wheel makes 2.5 revolutions per second. We want to write a model for the height in inches of the light as a function of time, seconds, given that the light is at its lowest point at time 0. All right, so just to kind of visualize what's going on, we've got these LED lights. They're going round and round and round and round as the bike goes along. And really, they're just talking about a model for the height of these. So although the lights themselves are going in a circle, the height of the lights is just kind of going up and down, up and down. It reaches a max height of 22 and a min height of 4. And it's going to have some kind of sinusoidal sort of look to it because it just keeps going round and round for the y position. So let's get all our parts here. We're going to start with the a value, the amplitude. That's going to be highest minus lowest point divided by 2, half the height basically. So 22 minus 4 over 2. That's 18 over 2, which is 9. And then for the b value, first we need the period. Now to get the period, let's see here. They said the wheel makes 2.5 revolutions per second. That's actually the frequency, I believe. So if our frequency is 2.5, that means that the period is 1 over that. And that means that the b value is 2 pi over 1 over 2.5. So same change flip, that's really 2 pi times 2.5, which is 5 pi. So a little bit of work to get the b value there. Now how about that k value, that midline? That's going to be the average of the highest and the lowest points. So 22 plus 4 over 2. That's 26 over 2, or 13. And now for the h value and the function, the key to this one is they said that the light was at its lowest point when t equals 0. So that if you just visualize the graph of the height of this thing, that means on the y-axis at time 0, we're at the bottom of the wave. So that means we can use the negative cosine function because that's the one where the cycle starts at the bottom. Negative cosine and an h value of 0. So putting it all together then, we're going to use the negative cosine model here. Negative a cosine b, x minus h plus k. So we're going to have negative 9 cosine of our b value of 5 pi, and then we have t minus 0, so we can just write t, plus the k value 13. For this problem, which is on the honors set, we have a table here, and in this table the time is measured in months, where t1 equals January, and you can speculate about the rest of these. They want us to write a model that gives the average monthly high temperature, d, as a function of time and interpret the period of the graph. So these are air temperatures in Las Vegas. So what we're going to do on this one, since temperature tends to be kind of an up and down cyclical sort of thing, we're going to try to model this with maybe a sinusoidal function. Let's start by going on Desmos and entering all this in a table. So here's Desmos. Let me do plus to get my table. And let me just do the t values first. So we got 1, 2, and I can just keep pressing enter until I get to 12 because it auto steps when you just have the same intervals there. And then up here, let me put in my temperatures. So we have 58, 63, 70, 78, 89, 99, 104, that's in July, 102, 94, 81, 67, and 57. Well, 57 is in December. I wouldn't mind that too much. So let's do a little zoom fit here just to see where all those are, just to get the lay of the land. And that definitely looks like kind of a cosine-y sort of curve there. So let's do a regression, and we will switch it from linear regression to sinusoidal regression. And it looks like it roughly follows a sinusoidal sort of pattern there. It's got an r squared of 0.987, which isn't bad. So they wanted us to write an equation. So that would be this equation right here. We can write this as d of t equals 22.900 and some change times sine of 0.542t minus all of this stuff here, plus this 80.919 out there. So here's all of that stuff. Now ultimately here they wanted us to interpret the period of this graph. So The b value is this 0.542 next to the t, and it would look more like a b value if we factored it out of this parentheses, but it is the b value. So if we do 2 pi over that, and I'll go back to Desmos to do this, just move this up so I can see it a bit. Let me just go down to the next entry. So we've got fraction 2 pi divided by 0.542, and that's roughly 11.593. So what this period is saying, that this is how long the cycle of these temperature changes is. It's saying that the temperature cycle lasts roughly 11.6 months. I mean, you could round it up to 12 if you wanted, but a little bit less than a year is this temperature cycle.